Okay, welcome to part one of our lecture video series for Monday, April 3rd, where we begin to discuss the idea of what an acid is and how we can identify it, what it does, all that good stuff. So as mentioned in our lecture plan video, when it comes to thinking about what an acid is, we actually have three different perspectives that we can utilize in order to characterize what an acid is, does, behaves like in a solution. So the first definition that we have is the one that you and I are probably most familiar with at this point based on our chemical nomenclature. This is known as the Arrhenius definition of acids. So according to the Arrhenius definition, acids are any kind of species or substance that contribute H plus ions to solution when dissolved. So we have seen things like our 6 strong acids, like hydrochloric acid, hydroiodic acid, hydrobromic acid, nitric acid. What else we got? We got sulfuric acid, and then perchloric acid. So if we're looking at a strong acid, then we are going to look at full dissociation. So for example, if I were to look at the dissociation of HCl into solution, I would generate H plus ions and Cl minus chloride ions. And because I see full dissociation, meaning my H plus and my Cl minus were completely separated from one another in solution, then this is what makes me a strong acid. And in particular, because I have generated H plus in solution, this is what makes me an Arrhenius acid. Similarly, for our weak acids, we still contribute H plus into solution. We just do so partially. So weak acids show partial dissociation into H plus and whatever anion was associated with that acid. So for example, if I were looking at acetic acid, which I write as CH3COOH, if I were to look at this thing in solution, this would show only partial dissociation into the acetate ion and that acidic H plus. So this partial dissociation is what makes us weak. However, we're still contributing H plus to solution, so according to the Arrhenius definition, acetic acid is still an acid. So when talking about an Arrhenius definition, I like to think about this as like what an acid looks like, right? It's not what it does chemically with something else. It's not how it reacts. It's just simply what an acid might look like in solution. So according to Arrhenius, anything that creates H plus ions, which I might refer to in the future as acidic protons into solution, then that is what makes us an acid. So let me make us a little note here. H plus I might call an acidic proton because if we remember, like the Bohr model for the hydrogen atom, it's got just a singular proton and a singular electron. So that's the hydrogen atom. There's no neutrons in the nucleus of hydrogen. And if I were to remove that electron, that 1s electron, to make H+, then it would simply be left with a proton, that proton left over in the nucleus. So this idea of an acidic proton is something that you might see me use interchangeably with this H+ ion, hydrogen ion. So our first definition, the Arrhenius definition, acids are things that put H+ or acidic protons into solution. In our next video, we're going to discuss a little bit more about what is it that acids do. So that is going to be coming up in video 2, which I'll see you then.